Hello everyone, welcome back to our SOLIDWORKS course. I hope that the bottom-up assembly approach that we learned in the previous videos was very clear. In this new video, we would be learning about the top-down approach. Let's first take a look at what is the top-down approach. I will show you this again with the help of a small sketch. In the bottom-up approach, we went from the bottom to the top. That is, we had individual components over here, and finally we created a complete assembly. And in between, these were our end steps, and in between we assigned them all sorts of mates and made them according to the design that we have created. So this was the bottom-up approach. Now, in the top-down approach, we will do the exact opposite of it. In the top-down approach, we don't have all our parts created over here at the first. But here we have, let's say I have an assembly made over here, like this. I will now create my parts in the middle layers over here of this approach. I will create my parts and then add them in my assembly. And then I will reach to my final complete assembly. Okay, so I hope now the basic difference between both these assemblies are clear. Here we have our individual components first ready, and then we move to the assembly mode and then add them and give them mates and then complete our assembly. Here we don't necessarily have all our components ready. We have a simple assembly and then we add all our, or rather we create new parts in the assembly itself. But talking about the top-down approach, it is kind of a theoretical approach. We don't always have an assembly ready and we cannot create all the parts in the assembly itself. So while creating assemblies or creating designs realistically, it is always a hybrid between the bottom-up approach and the top-down approach. Let's say you've created some random assembly over here and then you need to create a new part. Let's say a simple part like a pin or something similar. So you won't again create a new part, again then model it, save it, and then bring it into the assembly. You can simply create it over there itself, and then you can place it wherever you want, or rather create it at the place you want. In order to make this more clear, we will take a look at a small example and create a top-down assembly. I will show you what are the benefits of top-down assembly and how you can use them. Let's first take a look at our model or at our exercise for this video. We would be creating the simple turnbuckle for our exercise. Let's move to SOLIDWORKS and start creating our top-down assembly. We will launch SOLIDWORKS and then create our assembly using the top-down approach. I will press Ctrl N over here, and then next I will double click on assembly in order to create a new assembly. Now here it is asking me to import a part. I don't want to import a part, rather I want to create it over here. From the drop down of insert components, I will select new part. Now you can see that we are into the part mode and the first part over here has been added. What we will do here is that I will select the front plane and you can see directly now I am into the sketch mode. I will press Ctrl 8 and set it normal to the screens. You can see now that the front plane is normal. Next, what I will do here is that I will create the body of the turnbuckle. I will create a center line over here like this, a horizontal center line. I will end the line. Press escape, select the line, or rather the midpoint of the line. You can right click over here directly, select midpoint, press Ctrl and select the origin. When I leave Ctrl, I have the option over here that says make coincident. I will get into the smart dimensions command, give this line a distance or rather a dimension of 150 millimeters. Once I have done this, I will add another center line over here like this. Also, that line would also be passing from the origin. Once I have done this, I will select the normal line command and then create the profile that I want to be revolved. Yes, we would be creating the profile by using the revolve command. I will create a profile something like this. I will first draw a vertical line, then an inclined line, and then another horizontal line over here like this. What you can do here is that you can press Ctrl Z, delete the line, again get into the line command and create a line over here till the center point. I will press escape, again get into the line command by pressing L and then draw another line. Okay, I have snapped the center, I don't want it. So again I will press escape, get into the line command again by pressing the L button on the keyboard and then draw a line over here like this. Now I will press escape and start dimensioning it. I will get into the smart dimensions. I will give this a diametrical distance of 12 millimeters because I want the rod that would be entering here of 12 millimeters. Next, I want this point to be at a diametrical dimension. Okay, yes, I want a diametrical relation, or rather a diametrical dimension of 25 millimeters. Once I've done this, I know that, okay, we are still in the selection with the center line. I will press escape. I know that the distance horizontally for this line is 20 millimeters. I will click on OK and give it a dimension. Now I will give it the outer dimension. That is 50 millimeters, or rather a diametrical dimension of 50 millimeters. Once I have done this, you can see that now my profile is ready. I will get into the trim command. For that, I will press my right mouse button and drag my cursor downwards. Okay, we are still in the dimensions tab command, so I will press escape, exit it, and again press my right mouse button, drag my cursor downwards. Okay, we can't use it over here. It is not giving me the option to enter the trim command by using the mouse wheel. So I will press escape and simply enter the trim command from here. I will trim off this line. Now you can see here that now my sketch is still underdefined. I will now define it. Let's say I will make these 2 points vertical, and now that I've done it, my sketch is now fully defined. I will mirror my sketch over here like this. Press the right mouse button, select this line about which my profile is supposed to be created. Again I will press the right mouse button and create my profile. Once we have created our complete profile, now we will go ahead and revolve it. I will go to features, select revolved boss base. From here I will specify the axis of revolution, that is this one, and you can see in the preview that it is being generated. I will click on OK and generate my part over here like this. Next, what I will do is that I will go to the drop down of this and I will now start sketching on the top plane. Here you can notice that I am sketching on the top plane of my part so that I avoid all the other necessary confusions. I will select the top plane, go to sketch, press Ctrl 8, set it normal to the screens, and then from the center I will draw a center rectangle over here like this in order to create our cut that is in between. Now I will dimension this rectangle that we have created. I want a horizontal length of 90 millimeters and a vertical height over here of 32 millimeters. Once we have done this, I will again go to features, and from here I will select extruded cut. From the end condition options I will select through all both because I want a rectangular cut to be created in between over here. I will click on OK and generate my cut. You can see that now it is slowly taking shape. Next, what I will do here is that I will sketch on the front plane of my part. I will say sketch, press Ctrl 8 and then create another rectangle over here. This would be a corner rectangle starting from this vertex over here and ending somewhere on this edge. Here it is not giving me an option. Okay, the reference has been snapped and I placed my rectangle over there. I will press escape because I don't want to create another rectangle. Now I will simply give it a depth. I will get into the smart dimensions command, select this edge over here and give it a depth of 14 millimeters. Once I have done this, what I will do is that I will now create a center line that would be passing from the origin like this, and I will create a mirror of this sketch that we have created. This sketch would be mirrored about this line. I will press the right mouse button and then create the mirror. Now that we have generated our profile, I will go to features. From here I will select extruded boss base and again I will select through all both. You can see that this is how my cut would be generated. I will click on OK and generate my part. I will press Ctrl 7 and here you can see that now my socket of the turnbuckle has been created. Once we have done with creating our part, we will simply go here and specify edit the part mode, exit the part mode. I will press Ctrl Q and rebuild this part. Once we have created the first part over here, what I will do is that next I will create the rods of this turnbuckle. For that, I will go to the drop down over here, select new part, and first I have to specify on which plane would I be creating my sketch. I will specify this face as my plane. Once I am into again the sketch mode, what I will do, I will zoom over here and create a center with this edge as the reference. I will create it randomly. I will press escape and then I will select this circle that I have recently created, press Ctrl and select this edge over here. I will leave my control button and here you can see we have an option that says make co-radial, that is the radius of these two would always be the same. Once I have made this co-radial, you can see that now my sketch is fully defined. Once we have done this, now I will go to features and select extruded boss face. Now from here I will give the commands very clearly so that I can use the referencing over here in my assembly, and if I make any changes, the changes would be reflected over here. From here in the direction 1, I will say offset from surface. I will select this surface as my offset, and from here I will reverse the direction, also reverse the offset, that is in this direction, and now here I will mention my offset as 30 millimeters. I want this profile to be extruded in this direction and it is supposed to be at an offset of 30 millimeters from over here. Now I will go to the direction 2 over here. Again I will select offset from surface. I will turn this over and select this surface as my second offset face. Here again I will specify reverse offset. You can see that now it is being offsetted at a distance of 10 millimeters from this face in this direction. Here again I will specify my offset distance as 30 millimeters. Now if I click on OK, you can see that this is how I have created my extrusion by using the offset from surface command. All of the conditions that were mentioned over here are given very specifically. I will show you why. First, we will exit the part mode and now we will press Ctrl 7, set it into the isometric mode, press Ctrl Q in order to rebuild it. Now we have one final feature that is supposed to be added. I will go to the drop down over here, select mirror components. From the drop down I will select the right plane of my socket over here and I will specify this body that is supposed to be mirrored. I will click on OK and you can see here that my body has been mirrored. Now you can simply go here and rename your parts. I will click on this part over here, press F2 and rename it as socket. I will press enter and you can see here that it has been renamed. Next, what I will do is that I will select this part over here, press F2 and then rename it again. I want this to be renamed as rod. It is asking me if I want to rebuild and save the document first. Yes, I will rebuild and save the document. Once it is done, you can see that now my parts have been renamed and now I can identify them easily. Once I have done this, you can see that this is how my assembly was created. We didn't have these parts over here created at first. We created them in the assembly itself. Now what we will do here, I will demonstrate why a top-down approach is important. Let's say now I will double click on this over here and you can see that it is showing me all the parameters that were used in order to create this. Here it is also, it is supposed to show me the distance over here like this. This is what, okay, yes, that is the diameter of a circle that we had created like this. I will just dimension it properly. Okay, I will press Ctrl 7 first, again double click over here and then here you can see that this is the diameter of the circle that we had created. I will double click on this and edit it from here itself. Let's say I want it now to be 15 millimeters. I will simply enter 15 and then press the enter key on my keyboard. Now if I press Ctrl Q and rebuild this part, you can see that now because I had changed the diameter of this hole over here and I had given a reference, that is a sketch relation of co-radial to this edge over here, you can see that my pin has also changed. If I click on this edge over here, on the bottom side over here, you can see that the diameter is now 15. we did not give this any diameter, but we gave it a sketch relation of co-radial. I hope now you understood why we create parts in the top-down approach and how easy it is to accommodate all the changes in the parts if you have created right references while creating the part. Now let's say if I want to edit the length of this over here, I will again double click on the socket end and then I will change, let's say, from 150 to 200 millimeters. I will press the enter key, press Ctrl Q and rebuild my part. Here you can see that the length has been changed. But if you notice here, I will select both of these surfaces using the Ctrl key. And if you notice here, the distance has been maintained at 30 millimeters because we had offsetted this part of a rod at 30 millimeters from this face. Again, if you turn it around, select this face, press Ctrl and again select this face, you can see that now again the distance over here is 30 millimeters. This is how you can use sketch relations and all the other relations that we have applied over here, like the ones we use in offset surface while creating the extrude. I hope now you understood how important or how convenient it is to create simple parts in the assemblies itself. You don't have to create them separately and then import them. You can directly create them in the assembly mode. I also think that you are now clear with creating a new part in the assembly itself, and also you are acquainted with the procedure. Again, you can set it back to the normal mode over here by entering all the default values like this. I will make it to 12 from 15 again, press Ctrl Q and then rebuild it. I will press Ctrl 7, set it into the isometric mode and then rebuild it. Now we will again take a look at the property tab builder that we have added before. I will select this part over here, go to this option that says custom properties, and here you can see that the property tab has been applied automatically. From here I will give it a description of, let's say, socket. I will press apply and then again assign it a material of, let's say, cast alloy steel. Now once I have done this, you can see that it has updated its weight over here, that is 807 grams. I will select this now rod over here, go to custom properties, give it a description of rod. I will press enter. I should have not pressed enter. I will press apply. From materials, I will give it a material of cast alloy steel. I will press apply and you can see that this is how it has applied all the properties that we have given from over here currently. Now I want you to do a simple exercise. I want you to go ahead and create a drawing of this part over here. Create the bill of material and also show all the parts with the help of ballooning. In the bill of material, you need to have the item number in the first column, next the description, material, weight and the quantity. I hope that now you must be confident in order to create a bill of material. Also, I hope that this was a fun exercise and you understood how to create parts in the assembly itself. I will see you in the next one. Thank you.